All right, hello pre-cal. This is lesson 6.4 using trigonometry. So today you're going to be able to take a trig ratio, a trig equation, and use it to find other trig ratios. So today's assignment is called draw first, then trig, because it turns out that if you're given a trig equation, like sine of some angle is 4/5, then anytime you're given a trig equation, you can draw a related triangle. It's pretty easy because you already know that the 4 is the opposite side and the 5 is the hypotenuse. And because you know that, you can draw a triangle. Then we'd use the Pythagorean theorem to find the third side, and then we can find any other ratio that we want. So we're going to draw first and then trig. Let's see what we've got. Luckily, today's lesson is quite short. You can see all of these are just straight from Delta Math, which is really nice. So example 1, given that the sine of some angle, theta, is 60/61, and angle theta terminates in quadrant 1, then what is the value of tangent of theta? So what we're going to do is we're going to go ahead and draw a little picture of this given information. So first, we're given a trig equation here, and I always box it in a triangle because it kind of has a triangle shape, and that just helps me remember that I can draw a triangle. We also know that it terminates in quadrant 1. So angle is some angle in standard position. So here's my initial side, and I know that it terminates somewhere in quadrant 1. So look at that. There is my mystery angle theta. All I need to do now is turn it into a triangle. So I'm going to drop an altitude. And I know that this is a sine ratio. Sine. All right, that was someone calling about a elderly insurance care plan. I'm not there yet. Okay. The sine ratio is opposite over hypotenuse. So knowing that I've got my little angle theta here, remember this angle theta always has to be close to the origin. So theta is not up here. It's always next to the origin. The opposite side would then be 60, and the hypotenuse would be 61. So what we need to do is figure out this side length of the triangle. I'm going to call it x. And then we can use the Pythagorean theorem to find the third side. So x squared plus 60 squared equals 61 squared. I have no idea what 61 squared is. Wow, okay. So, what's 60 squared? 3,600, yeah, okay. All right, so x squared plus 3,600 equals 3,721. And we're going to subtract the 3,600. So we get x squared equals 121. Hey, that's cool. And then we can take a square root of both sides. Now, we are no longer solving simply for the hypotenuse. The hypotenuse has to be positive because it functions like a radius of a circle, and we know that a radius of a circle is always positive. But because we're talking about x lengths and y lengths now as well, in the unit circle, x's and y's can be positive or negative. So we do want to remember now, we have to be very careful that in this case, we could have a positive or a negative x value. But since we're in quadrant 1, all these x values have to be positive. So we're going to take positive 11. So now the third side is 11. And now we can figure out the tangent according to the angle theta that we drew. Tangent is opposite over adjacent. So that's going to be 60/11. And there you go. So we're using what was given to draw a triangle and then figure out the ratio we need. So try another. Example B, given that tangent of some angle equals negative 56 over 33, and that it terminates in quadrant 2, what is the value of cosine of theta? So again, I'm going to draw a picture. Here, our angle theta is terminating in quadrant 2. So I'm going to draw my angle theta here, and it's opening up, and it terminates here in quadrant 2. So this is theta, and we're going to turn it into a triangle by dropping our trusty rusty altitude like we always do. And so we create our little boxed-in reference triangle. I'm going to call it theta prime. So it's our reference triangle, and give a little tick mark here, that's prime. So theta prime is just that reference triangle we use to label our sides. So we're going to use this pink little triangle here, and tangent is opposite over adjacent. So using my little reference angle here, theta prime, the opposite side would be here. That's a positive value. And then the adjacent side is here along the x-axis. That actually gets the negative 33. How do I know that? Well, this is going up, so it must be positive. This side is moving left, so that must be negative. That's why. All right, so now once again, we have to find this, I'm going to call it R for radius, because again, we have this like part of a circle here. It's not one though, it's not a unit circle. So, all right, leg squared. Oh, 33 squared. Oh, that doesn't look like. Okay, negative 33 quantity squared plus 56 squared equals our radius squared. Oh, these are big numbers. Definitely need a calculator here. 33 squared is 1089. 56 squared is 3136. And so we get 4225, and I can take a square root of that answer. Whoa, that's interesting, a question mark. Oh, funny. And we get R equals 65. And again, this is a radius, so it has to be positive. Wow, these are crazy. These are Pythagorean triples. So 11, 60, 61, and 33, 56, 55, they're all three sets of numbers that form a right triangle. It's called a Pythagorean triple. I don't know these. Crazy. Common ones are 3, 4, 5, 5, 12, 13. Oh, that's this one. No, it's not. So there's a Pythagorean triple, there's a Pythagorean triple, or 7, 24, 25. But yeah, now here's some more. I didn't know those. So those are common Pythagorean triples. All right, I digress. Here we go. Now that we've completed our triangle, now we can figure out the cosine of that angle that we just drew. And it's technically theta, but we look at the reference triangle here. Cosine is adjacent over hypotenuse. So adjacent to our reference angle would be here, negative 33, and the hypotenuse is 65. And it does not reduce, so we leave it at that. All right, a couple more, then we're done. Easy day. All right, so given that tangent of some angle, so I'm going to get to draw a little triangle there, is negative 28 over 45, and that angle terminates in quadrant 4. What is the value of sine of theta? All right, draw first. So we have an angle that terminates in quadrant 4. So here's my initial side, and it opens up, and there's theta, big angle theta, terminates in quadrant 4. And then, to make my little reference triangle, I'm just going to drop an altitude from somewhere so that I can see my reference triangle, which I'm calling theta prime. I could call it whatever I want, but theta prime is good. Now, using that reference triangle, I'm going to label my opposite and adjacent side. So the opposite, is it 28 or negative 28? Negative 28, because this is going down to get to this point on the terminal side. And our adjacent side would be positive 45, since it's moving to the right and then down. Can they both be negative? No, because then it would have negative 28 over negative 45, which would give us a positive result. So that wouldn't be the same at all. All right, so we're going to figure out this third side again. So let's see, 45 squared plus negative 28 squared equals the radius squared. Excuse me. I'm going to just plug that all into my calculator. 45 squared plus 28 squared. There we go, 2809. And then I can take a square root. And so I get a radius of 53. And again, it is a radius of a circle, so it has to be positive. The x and the y can be positive or negative. All right, now that our triangle is complete, we can do the sine of our angle that we drew. Using our reference triangle, sine would be opposite over hypotenuse. So that would be opposite is negative 28 over hypotenuse of 53. I'm going to sneeze. All right, given secant of some angle A, oh look, they're no longer using theta. They switched to a generic A. It doesn't matter what they call the angle. It's like using, a Y instead of an X, or a D instead of an X, using any other letter. Same idea. We have some angle that terminates now in quadrant 3. We want to find the exact value of tangent of A. So let's draw our angle. So angle is in standard position, and it's opening up, and it's terminating here in quadrant 3. So there's angle A. I'm going to make it a triangle by dropping an altitude up to that x-axis there. Okay. And that creates my little, I'm going to call it A prime, my little reference triangle there that we've filled in. Secant is the reciprocal of cosine. Cosine of some angle is adjacent over hypotenuse. So secant is hypotenuse over adjacent. So the hypotenuse is 11. Remember, that's always positive. And then the adjacent side, this would be the opposite side. The adjacent side here would be negative radical 85. All right, so now we need to find this third side. And since it's a vertical, I'm going to call it y. Like this is the x, and this would be the y direction. All right, so leg squared plus leg squared equals the hypotenuse squared. Negative radical 85 times negative radical 85 is 85. Equals 121. 121 minus 85 is 36. And then we can take a square root. Ooh, so when we take a square root, don't forget plus or minus. What should our answer be? Negative 6. Why is it negative 6? Because it's going down. We are in the third quadrant. X and Y must be negative. Really important. All right, now we need to figure out tangent of that angle that we drew would be opposite over adjacent. So opposite is negative 6. Adjacent is negative radical 85. Well, that's going to turn positive, but I do need to rationalize. You know what? I'm curious if 85 can be simplified. Let me look. I know it divides by 5. Oh, 5 times 17. Those are both prime, so it does not simplify. So I get positive, turns positive result here. 6 radical 85 over 85. There we go. And it doesn't reduce. That's it. So look for rationalizing. Remember, x and y can be positive or negative. A hypotenuse is like a radius of a circle, so it has to be a positive. And that's pretty much it. So if you can draw an angle in a particular quadrant, and if you can figure out the third side of the triangle, then do the ratio, you're good. Oh, one more. Look at that. How about that? Psych, fooled you. You thought we were done, didn't you? Me too. Okay. Given secant of A equals negative 16 over radical 207. And angle A is in quadrant 2. Find the exact value of sine of A in the simplest radical form. All right, so I'm going to draw my picture here. We are in quadrant 2. So I've got my angle in standard position, opening up and landing here in quadrant 2. I'm going to go ahead and extend that. All right, and I'm going to go ahead and draw my reference triangle. So pick a point and drop it to create my reference triangle here. Secant is hypotenuse over adjacent. So that's going to be 16 over the adjacent side of the square root of 207, and that is negative. And so I need to figure out the third side. Again, it's a vertical side, so I'm going to call it y. So y squared plus negative radical 207 squared equals 16 squared. Well, that's just 207 equals 256. Is that right? I think so. Right, 256. And then if we subtract 207, I get 49. And then the square root of both sides would be plus or minus plus or minus 7. So we're going to take the positive 7. I don't know what number that is, but I meant it to be a 7. All right, so this is 7, and it's positive because we're in quadrant 2. X is negative, Y values are positive. All right, and then now that we've completed our triangle, we can figure out what is the sine according to this angle triangle I drew here. Sine would be opposite over hypotenuse. So looking from our little reference angle here, because there's no triangle here, right? The triangle is here. Opposite would be 7. Hypotenuse, 16. Easy peasy. All right, ladies and gentlemen, draw your picture, complete the triangle, then do your ratio. Good to go. That's it, ladies and gentlemen. That's trigonometry in a nutshell. We're going to do all this over and over and over again until you get really, really good at it. Have a great day, folks.